안녕하십니까. 로데 슈바르즈 코리아의 최지홍입니다. 예, 오늘도 예전처럼 항상 그렇듯이 웨비나로 여러분께 찾아뵙게 되었습니다. 오늘 저희가 준비한 웨비나는 레드캡 디바이스 테스팅에 관련된 내용입니다. 그래서 오늘 관련된 내용으로 여러분께 저희 본사에서 글로벌로 진행했던 웨비나 화면과 내용들을 자막으로 처리해서 여러분과 함께 나눌 계획입니다. 오늘 현장에서 여러분들께 또 자세한 설명과 어떤 내용들을 말씀을 드리기 위해서 저희 로데 슈바르즈 코리아 기술 지원팀에서 근무하고 있는 김종훈 매니저님 함께 자리해 주셨습니다. 김종훈 매니저님 인사해 주시죠.
안녕하십니까. 로데 슈바르즈의 김종훈이라고 합니다. 저는 와이어리스 커뮤니케이션의 프로토콜 R&D 솔루션을 담당하고 있습니다.
네, 저희 로데 슈바르즈 코리아 여러분들 아마 다들 아실 것 같아요. 저희가 테스트 측정 계측에 관련된 솔루션들을 공급을 하고 있습니다. 그 중에서 저희가 이제 와이어리스 커뮤니케이션, 흔히 우리가 이제 이동통신이라든지 혹은 와이파이와 같은 UWB, 이런 항목들을 시험할 수 있는 솔루션들도 저희가 국내에 공급을 하고 있고요. 방금 말씀 들으신 것처럼 저희 이제 그 중에서도 이 프로토콜에 관련된 내용으로 기술 지원을 필드에서 진행을 해주고 계시고요. 굉장히 오랜 경험을 통해서 또 여러분들께, 고객분들께 또 맞춤형 어떤 지원을 해드리고 있다는 점을 다시 한번 말씀을 드리고요. 오늘 진행을 위해서 김종호 매니저님, 주제가 레드캡이라고 되어 있습니다. 네. 레드캡, 정확하게 말하면 Reduced Capability라고 이야기를 하죠.
네네.
예.
맞습니다.
요 레드캡이 어떤 건지 먼저 개념을 좀 설명을 해 주실 수 있을까요?
5G NR 릴리즈 17에서 NR 라이트라고 불리는 Reduced Capability, 즉 줄여서 레드캡이라고 NR IoT 무선 사양입니다. 레드캡은 제한된 NR 피처를 이제 지원함으로써 복잡성이 낮아지면서 비용 대비 효율은 높아지고, 그다음에 저전력을 지원하기 때문에 이 새로운 보급형 IoT 설계를 위해서 나온 피처라고 볼 수 있습니다.
IoT라고 하면 지금 이거 인터넷 오브 띵스, 우리가 흔히 이야기하는 사물인터넷이 될 것 같은데,
네네.
지금 설명해 주신 내용으로 봤을 때는 레드캡이라고 하는 내용이 우리가 흔히 이야기하는 5G NR, 스마트폰을 타겟으로 하는 건 아닌 것 같습니다. 그러면 이 레드캡 단말이 특별히 어떤 종류가 분야라든지 이런 부분이 따로 있을까요? 기존에 어떤 우리 흔히 생각하고 있는 이 5G 스마트폰을 대비했을 때 어떤 시험 항목이라든지 요구사항이라든지 이런 부분들이 지금 아까도 NR 라이트라고 표현을 해주셨는데, 예, 어떻게 달라질 수 있는 건지 이런 부분들 간단하게 좀 얘기해 주실 수 있을까요?
일단은 단말 종류를 말씀을 하시는 거면 이제 기존 LTE 때도 IoT 기기가 웨어러블 같은 기기가 분명히 있었었고요. 근데 NR에 들어와서는 이제 기존의 LTE IoT 기기 플러스 알파가 될 수 있습니다. 이게 기존 대비 이제 유사한 효율성을 이제 가지면서도 이제 높은 스루풋을 이제 지원을 하고, 그다음에 낮은 레이턴시를 지원을 하기 때문에 이제 기존보다는 더 많은 확장성을 가지고 있고요. 이게 특히 이제 5G 특화망이 이제 사용될 수 있는 이제 산업 영역에서 이제 무선 센서, 스마트 카메라, 그다음에 웨어러블 기기, 그다음에 리모트 통신 모듈 쪽에 이제 적용을 할 수 있기 때문에 이제 인더스트리 4.0을 좀 가속화시킬 수 있다고 볼 수 있죠. 네.
그러면 그냥 가장 간단하게 표현하자면 기존의 5G에서 타겟팅하던 이 사물인터넷, 이 IoT에 대한 부분에서 약간의 어떤 좀 더 최적화라고 해야 될까요? 그런 부분과 업그레이드, 아까 말씀하신 데이터 스루풋, 이런 부분들을 조금 더 확장한 개념들로 이제 이야기를 하게 되는 거고, 그렇기 때문에 어떤 활용성에서 좀 더 나은 모습을 보여줄 수 있고, 이 내용이 실제로 우리가 국내에서도 흔히 이야기하고 있는 5G 특화망, 프라이빗 네트워크라고 표현을 하죠. 이 부분까지 연계되는 내용으로 우리가 생각할 수 있다. 이렇게 생각을 하면 될까요?
네, 맞습니다.
예. 이게 5G NR 자체가 최초에 태어났을 때부터 우리가 기존에 생각해왔던 스마트폰뿐만이 아니라 IoT라든지 혹은 초저지연 무선 통신이라고 보통 이야기하죠. URL이라고 부르는 이런 다양한 어플리케이션들을 목표로 했었기 때문에 이런 부분들에 있어서 좀 더 이렇게 각 분야별로 특화된 모습들이 나타나는 게 아닌가, 이제 이런 생각이 들고요. 이런 어떤 뭐라고 해야 될까요? 확장이라면 확장이 될 수도 있고 업그레이드라면 업그레이드가 될 수도 있을 것 같은데 이런 부분들이 릴리즈 17을 통해서 나타난 모습이 오늘 말씀드리는 어떤 레드캡, 리듀스드 캐퍼빌리티다. 이런 식으로 이야기를 정리할 수 있을 것 같네요. 그러면 어떤 이게 아무래도 일반 스마트폰을 대상으로 하는 게 아니기 때문에 시험 항목도 뭔가 어떤 면에서는 조금 크리테리아라고 보통 표현하죠. 이런 게 좀 낮아졌다라든지 뭐 이런 차이점들이 있을까요? 시험이라는 면에서 봤을 때.
그렇지는 않습니다. 이 시험 측면에서는 기존의 NR 피처를 좀 제한한 것 뿐이지 시험 항목이나 시험 방식은 기존 NR하고 동일하기 때문에 큰 차이는 없습니다.
네. 시험 자체로 봤을 때는 기존에 있던 어떤 단말 시험에서 연장선상이라는 정도로 생각을 해보면 될 것 같네요. 알겠습니다. 그러면 오늘 이제 곧 시작을 해야 될 것 같은데 오늘 저희가 준비한 저희 본사에서 준비했던 영상 이 부분에 대해서 이제 어떤 식의 내용들이 나올지 간단하게 한번 예고편 정도로 좀 설명을 좀 해주시면 어떨까요?
일단 레드캡에 대한 오버뷰 및 시장 현황에 대해서 소개를 드리고요. 그 다음 레드캡에 대한 좀 더 테크니컬한 부분과 그 다음에 저희 RNS 솔루션에 대해서 소개해 드릴 겁니다.
그럼 저희 솔루션을 이용한 어떤 시험을 어떻게 구현이 되어 있는지 이런 얘기도 좀 간단하게 나올 수 있겠네요.
네.
알겠습니다. 저희 본사에서 진행했던 글로벌 영상, 웨비나 영상이 약 한 45분 조금 넘는 길이입니다. 그래서 시간 관계상 지금부터 준비를 해야 될 것 같고요. 그래서 오늘 흔히 저희가 계속 해왔듯이 먼저 동영상 같이 보시고 그 이후에 이제 중간에 올려주시는 질문들에 대해서 저희가 동영상 이후에 한꺼번에 정리해서 답변을 드릴 수 있도록 그렇게 준비를 해보도록 하겠습니다. 중간에 보시면서 혹시라도 궁금한 점이 있으시거나 추가적으로 말씀해 주실 내용들 어떤 내용이든 괜찮습니다. 중간중간 채팅으로 올려서 함께 해주시면 좋을 것 같고요. 그 내용 중에서 저희가 답변을 준비할 수 있도록 그렇게 해보겠습니다. 네, 지금부터는 저희 준비된 영상 함께 보시면서 내용 보시겠습니다.
Hello and welcome. We're thrilled to have you join us for this informative webinar on 5G RedCap device testing. Our presentation today is divided in two sections, the first of which provides an overview of the RedCap market through examining use cases, motivations, and various IoT technologies. The second part focuses on technical aspects, as well as thorough analysis of the testing considerations and challenges associated with these RedCap devices. Finally, we will conclude our webinar with a live demonstration of our state-of-the-art testing solution. My name is Gotze and I am excited to be later joined by Manuel, who will share his expertise on the technical aspects and provide a demo of our innovative solution. Let's dive right in. So what we see from market perspective today, 5G RedCap has two main divisions, two different serving markets. One is the consumer IoT with wearables, extended reality or future extended reality, AR type of wearables, health monitors, and etc. And the other one is about fueling the smart factory or the industrial IoT market segment with the surveillance camera, different type of robots, connected AGVs, and etc. In terms of what 5G devices bring to the table for the IoT use cases, if you see this chart on the y-axis, we have the device complexity going from low to high. On the x-axis, we have the device performance going from low to high. So if we map today's technologies for 5G, you will see that the enhanced mobile broadband or the very ultra reliable low latency use cases are with the highest performance and complexity and the highest throughput. Then we have our lowest complexity and delay tolerant technologies like eMTC and NB-IoT fueling low-end variables, sensors for agriculture, farming, utility meters, and etc. And really the meat in between, it is the RedCap, where we have devices that are, let's say, high-end logistics devices, wearables, sensors, cameras, and etc. And what you will notice due to this reduced complexity in these devices from the highest performance devices, you will note that also the cost of these devices is considerably lower, around 60%, especially in FR1 cases. The The red ring signifies the actual size of how much cost is being saved, comparable to enhanced mobile broadband, for example. The second chart that I would like to show is actually a chart that maps the different use cases and different type of devices according to throughput and mobility. So if you see from the very corner of this chart, we have different type of use cases such as connected elevator, industrial sensors, or alarm panels with their different latency requirements and a different need for RedCap devices, followed by video surveillance, which is around between 10 to 50 megabits per second use case with 50 to 100 millisecond latency, and then followed by AR. So this initial use cases, as you see, they're more about fixed location without any mobility. Then as we go through the mobility axis, you will see that we would need certain type of mobility for AR, VR cases, but definitely then the mobility aspect comes with the AGV and smart delivery robots, the drones, the different smartwatches, the connected car, but also we see the need for RedCap devices for enablement of featured phones or public safety devices for police and mission critical devices. Another aspect that it's interesting use case for RedCap is the so-called MiFi router or mobile router that can be put also in vehicle, cars, on the move and etc., or even to have broadband connectivity to remote homes and etc. Now, one important aspect for RedCap is that the devices itself really work only over 5G standalone network due to a lot of reduced reduced features that they have. So one important aspect is that in order for RedCap to scale, we need 5G standalone networks as well to scale and be deployed. So on this chart that you see on the left side, we see the current state of 5G operators. At the moment, we're talking about 532 operators, out of which 254 are commercial, and out of which only 41 are currently 5G standalone. But in the second block, you will see that already there are 75 network operators who are deploying standalone services. And another important market factor is that already we have around more than 1,000 5G private networks, and also a fraction of those are becoming standalone. So what we see also from the map on the right, or the global map chart, is that the dark green countries or regions are really regions that have already implemented 5G standalone networks. And due to this fact, what we see from a market perspective is really the Asian region, really followed by China or propelled by China, and also the North American region will be the first regions where RedCap devices will really take off with the different use cases that I have mentioned before. If we see another market insight coming from Counterpoint in the number of cellular IoT connections or installed base together with a forecast, you will see that we are just yet starting to grow the IoT landscape. And what we see already, it is the fastest growing use case in terms of mobile technology. The whole IoT use case is growing by 10.8% already year on year. And you will see this red line, which is 4G Cat 1 and Cat 1 bis technology. It is predicted to grow, which means we're not yet in its peak. More importantly is what we see here. Due to this technology, which will be a long-term technology, we see basically declining over a period after 10 years because IoT is a long-term technology. We see RedCap already starting somewhere in this year, and slowly, gradually picking the market year after year, and probably having a mass market scale somewhere after 27 or 28. Of course, China leads the IoT markets in terms of connections, followed by Europe and North America. Narrowband IoT technology, it dominates China at the moment, while LTE-M is preferred in Australia, Japan, and North America, where Europe supports both. And 4G and NB-IoT currently are the most preferred cellular IoT application. So definitely LTE IoT technology is on the rise, and this is what we see today from a market perspective. But of course, 5G as a technology has its own advantages, and the technology and the market needs to prepare for the next wave or the successor of IoT technologies within 5G. Therefore, as you see on the left chart, you see the various categories of LTE devices and 5G devices. So you see this migration from 4G IoT technology to 5G. We have NB-IoT and LTE use cases being ported in coexistence to 5G. And then you see today the main use case for RedCap release 17 with its performance is really to substitute the LTE Cat 4 device types. And what's coming in release 18 is this lower bandwidth device with 5 megahertz bandwidth, which will substitute the LTE Cat 1 device. So if you see the table on the right, we have as a comparison the different technologies like 5G NR, 5G RedCap with one transmit to receive type of antennas, 5G RedCap with one transmit, one receive antenna, the Cat 4 and Cat 1, Cat bis technical details and characteristics. So what is important here is to see that the RedCap devices are a substitute for Cat 4 because we're talking about 50 megabits per second in upload and 150 megabits per second in download. And of course, with the different modes of FDD and TDD and the different configuration types, these downloads vary. What is important is also that the power consumption of the RedCap devices is almost the same as Cat 4 devices. We're talking 120 to 160 milliamperes, and in idle 12 to 22 milliamperes. What is important, and these are the features to go for RedCap devices, what is not supported by LTE IoT technologies, specifically when it comes to network slicing as a feature, this will be supported on a 5G RedCap device, allowing for more use cases and even streamlined service QoS type of characteristics. 5G LAN or Ethernet PDU capability, it's definitely supported in 5G RedCap devices, which allows for, let's say, simplified routing and connectivity between enterprises, factory floors, and etc. Voice, we're talking about voice over NR. Mobility is supported across all these technologies. And of course, NTN is something that is already discussed whether to be supported and most probably will be supported in a RedCap devices, which allows for global continuous coverage depending on the use case. And of course, here a most important factor is the cost of the modem. So far, definitely a Cat 4 device costs somewhere between $5 to $10. Where Cat 1, it's already $1 to $5, but we see the RedCaps ranging between $5 to $40 in the highest complexity. But we do expect that over time and with the scale of these devices, as it was the case with LTE, the prices will drop. Keep in mind, these are costs not for the actual wireless modules, but these are costs of the modems and the chipsets that they are built in the modules themselves. Another important slide for you. This is a list of the optimized features as an overview that are being defined in release 17 on what a RedCap device needs as optimized features and to become a RedCap device. So here on a high level, a bandwidth reduction with maximum bandwidth of 20 megahertz in FR1 and 100 megahertz in FR2. The number of antennas is being optimized or reduced from one or two receiving antennas to a single transmit antennas. Of course, maximum modulation is up to 64 QAMs, even though flexibly the device can even support higher modulations, but this is demanded for the RedCap device types. And of course, there is the half duplex operations, reduced capabilities for mobility scenarios and multi-carrier operations, identification to the network, signaling, shorter RLC and PDCP sequence numbers from 18 bits to 12 bits, a lower transmit power, and of course, we expect that only fewer frequency bands will be supported. So this is what is held on a high level in release 17 and already in release 18, which is also a very anticipated release for RedCap devices. This is a further reduction of bandwidth to 5 megahertz, which can enable this 10 megabits per second peak data rate, which substitutes or evolves the Cat 1 bis modules. we're talking about future railway mobile communication systems to have this GSM-R type of devices. RedCap for mission critical devices, RedCap side link support, especially in automotive V2X areas, and enhancements for narrowband positioning. And also we already for release 19, there is a study to even further reduce the complexity of RedCap. And you see the below table kind of a summary of the different peak rates of enhanced mobile broadband and different RedCap 17 and 18 type of devices with their cost assessment reductions as well. So a RedCap device, since we're talking about IoT ecosystem, one important factor definitely is the power saving aspect and how as a future IoT device has the ability to save power. And there are already a lot of mechanisms existing from release 15, 16 that are complementary to the release 17 logic, and this is where this slide comes into play, which is what we call the power saving cluster. So we have the enhanced mechanisms and innovations like wake up signals, the relaxed measurements, adaptive bandwidths. Then we have the hardware restrictions and reduced capability like lower power class, single antenna, half duplex operations, bandwidth restrictions. And then the actual operational enhancements like discontinuous receptions or discontinuous reception for RedCap, the different sleep modes, power saving modes, signaling reduction and cross-slot scheduling, and etc. So these are some of the mechanisms on a high level how a RedCap device can really have a power saving mechanism. Now, what we see, and this is an important slide, even though it's anonymized, these are all our customers that we're talking to, separated in different groups. So these are the different waves of development and adoption of RedCap ecosystems. So it's a good, let's say, a radar for us to understand how the ecosystem evolves. And of course, ecosystem starts with chipset manufacturers. And as you see already, there are already 13 vendors that have roadmap RedCap device development as chipsets or supporting RedCap chipsets. So already today we're talking with 6 chipset vendors. Right after that wave of chipset development starts the vendor development, and there are also a big number of vendors where we expect after 26 that a mass market of devices will evolve where even more vendors appear on the market. And already we're in talks with MNOs and test houses that are in need of testing and verifying the RedCap devices to be able to penetrate the market. So in a nutshell, the market is developing and no doubt that market is happening, mainly because it's an evolution to LTE within having an IoT use case natively supported in 5G, but also with all the different benefits that 5G RedCap devices bring, as explained before. We as Rohde and Schwarz have already worked and announced this in different press releases. So already we'd work with a number of chipset manufacturers to help them bring up their chipset in the R&D development stages. Then we have also pushed the test cases, and we are currently leading in the number of GCF validated 5G RedCap conformance test cases. But also we're very concentrated, let's say, on the Chinese market with all the different use cases that are being propelled in this market. And currently China, we would say, is the most active market for RedCap devices and use cases. So with this, I would like to conclude the first part of the presentation, which was mainly about the market. And right after me, Manuel will join in order to delve into the technical aspects and demoing our solution.
After the little excerpt into market size and use cases of RedCap, I would like to go a bit deeper into the technical aspects of RedCap device testing, especially RedCap device testing with our CMX 500. So on the next slide, I have summarized the typical aspects of a RedCap device compared to a normal 5G phone. And as Gotze already said, those are the typical features that are relevant to a RedCap device, or to call it a RedCap device as such. And the most important thing is that a RedCap device only has to support in FR1 up to 20 megahertz and in FR2 up to 100 megahertz. From an antenna complexity point of view, we are talking about 1 or 2 receive antennas and maximum 1 uplink antenna of the device. Also compared to other 5G devices, 256 QM or now in release 17 we have 1024 QM. The downlink modulation scheme is typically 64 QM, which also reduces the complexity and also the bandwidth of the device itself. What is definitely new for a RedCap device is that a RedCap device typically is implemented in half duplex. So it can on one point in time only receive or send data, but it is allowed to also have full duplex FDD, which most of the devices currently are using. But we will later also see devices that have half duplex FDD implemented. As Gotze already mentioned, also lower transmit power is one point, but actually here we have a new power class 7 for FR2. In FR1 we keep the power class 3 typically, so this is what we can currently see in the market. And since RedCap is also addressing stationary devices like surveillance cameras or industrial routers and so on, we also have limited mobility and handovers, which also reduces the complexity of testing here. I already mentioned, but here just to summarize once again for you, if you have a look at a typical RedCap device in FR1, as you can see it here, maximum bandwidth is 20 megahertz. We have typically 1 receive antenna, or in case we have 2 receive antenna, the UE is allowed to do also downlink MIMO 2x2 in FR1. FR2 is specified, as we already said, but we don't see so much activity in FR2 for RedCap at the moment. This might, of course, change also in the future when we talk about industrial routers and so on. And here we have 2 receive antennas, and the UE is able to operate either in SISO or in downlink MIMO 2x2. And as I already mentioned, and this really reduces the complexity for uplink testing. We have only 1 transmit antenna, and that means we only have SISO here and also cannot do any uplink carrier aggregation and so on. There's simply only 1 transmit antenna of the device. Gotze also already mentioned what dramatically reduces the complexity is that there's no carrier aggregation involved. We have a pure standalone functionality, so there's no LTE involved. We have not so many band combinations as we see for LTE and FR1 or FR2. And also here, all those limitations of the device really bring down the complexity, and we are talking about really streamlined testing use cases which you have to test against the RedCap device. However, since we are talking about release 17, so RedCap as a release 17 feature, there might be other release 15, release 17 features that might have an influence on a RedCap device. Yeah? So even if we talk about chipsets and modems, RedCap modems of release 17, they might use other features from release 15, release 16, and release 17 to improve the performance of such a RedCap device. And in this slide here, you can see a summary of rather useful release 15 to 17 features, but also some others which might not so be useful for a RedCap device. And just to dive deep, a bit deeper into these features here, there are a lot of power saving features in release 16. So Gotze has mentioned wake up signal, for example, cross-slot scheduling. All these features help to improve the power consumption of a device. And typically RedCap devices that we see in the market right now will also make use of these release 16 functionalities. Positioning is one big topic. Just think about a module being used for tracking in a standalone network. Positioning is one topic here. And another topic is also to improve battery life when it comes to data transmission. And sometimes it's just single bits and single bytes which have to be transmitted. And why opening up a whole IP layer on that? So there will be features like small data transmission, or even transmitting data in the RUDGE preamble, like two-step RUDGE or even side-link. Gotze has mentioned this already. So those are other useful release 15 to release 17 features that might have an impact on the RedCap device. And of course, those features need to be thoroughly tested. There are some others in release 17, just to mention maybe multisim. Multisim has been around for quite some time, but actually in release 17 it has been brought into the 3GPP specification. We will see if this will also make it into RedCap devices. At the moment, this is not the focus here. Same as multicast, broadcast. This is something which might come up in the future, but we don't see those features requested for RedCap right now. Okay, so what are the technical aspects one has to test when it comes to a RedCap device? And the first thing is about accessing the network of the RedCap device. The problem is there are no RedCap cells out there, and the RedCap device has to work in coexistence with other normal 5G devices. And in order for the network to steer those devices and to do the right scheduling and so on, there are new system information elements in 3GPP defined in order to allow RedCap devices or bar the cell for those devices. And those RedCap specific information elements in the system information can appear in the most important system information broadcast message, which is the SIP1, because here the device really gets information if the cell is barred for that specific capability of the device, or if the device can enter the network. But also if it has to do relaxed measurements for stationary devices, for example, we have SIP2. And also for the neighbor cells and interfrequency carrier infos, we need to know if a RedCap device, for example, is allowed on the neighbor cells. And here we have SIP4. How does that actually work? As I mentioned, the network can restrict access on a cell level. Yeah, so specific for RedCap features. And as I mentioned, there is no RedCap only cell. So the cell itself or the network itself has to handle the normal 5G devices and the RedCap device. But the problem might be that there are many RedCap devices, and still you need to make sure that everybody gets a right load of scheduling and so on, and doesn't congest the network. And actually, there are some ways of steering the devices into the network. So, for example, in SIP1, you can give some tags or some information that the cell is barred for devices that have, for example, only one receive antenna. So you can really restrict if this is a RedCap device with only one receive antenna, this device is not allowed in that network. Or same for two receive antennas, or for devices that have half duplex implemented. So in that case, if the device reads those information, it knows, okay, I'm not allowed to enter that cell because maybe that cell is reserved for other purposes. The same for the scheduling. So usually if a 5G device enters the network, it also gets information about the parts of bandwidth it can use in the network. And typically, for a normal 5G phone, what is mandatory is that the network schedules a common bandwidth part for all devices. The problem is now, if the network schedules bandwidth parts to devices that is larger than the capability of the device, we will have a problem because the device can never camp on because it cannot support this bandwidth part. And to overcome this problem, 3GPP has defined two ways. So either the network is signaling a RedCap specific bandwidth part for RedCap only devices, or dedicated bandwidth parts that can have a validity for normal 5G devices and for RedCap devices. So there are many ways to steer that. And actually bandwidth part testing, bandwidth part switching is one part that is a crucial part for RedCap testing here. Another thing is, in order to tell the network that a device is a RedCap device, there are several ways. So usually this happens when the device reports its capabilities. So UE capability is one part, but this might be too late for the network. So there are some new ways how the device can even tell the network that I am a RedCap device. And one thing could be in the random access preamble, it can tell the network in message A that and with specific RUTCH partitioning in SIP1 that only parts of these RUTCH partitions should be used by the RedCap device. So this is one part. Or by dedicated logical channel IDs. So for example, here in the RUTCH procedure, and this is a typical 4-step random access procedure, but there might be ways to shorten that, and the feature is called 2-step RUTCH, where even in message 1, for example, the UE can tell the network that it is a RedCap device. So just keep in mind, 4-step RUTCH, 2-step RUTCH, those are features that in early R&D we need in order to verify that the device is accessing the network correctly. And also a crucial part is, I mentioned already, half-duplex FDD operation, which wasn't really allowed for normal 5G devices. There's one problem with half-duplex FDD. If you give half-duplex scheduling to each and every device in the network, you very quickly can congest the network, because you always have one direction. You have either receive or send of the device, and you have to thoroughly schedule the devices in the network here. However, half-duplex FDD operation is one way for a UE to shrink the cost, because the UE doesn't need expensive filters to divide the uplink from the downlink. So we will see, as I said, half-duplex FDD devices pretty soon for RedCap. And also here, we need a way how to test that in the lab, but also in later in real network conditions. So which type of measurements do we actually support on the CMX500 when it comes to RedCap device testing? I will show you right now. So the most important information probably you're all looking for is what is the typical configuration and which type of software do I need in order to test my RedCap devices, no matter if it's R&D, RF testing, protocol testing, application testing. So what you see here in this slide is our CMX500 mobile radio tester for 5G, which currently supports LTE, 5G FR1, FR2, and also Wi-Fi. And in this configuration that you see here, which is our OBT Lite, it's the perfect configuration to test RedCap devices in the lab. So what you see is the OBT Lite comes with one RF unit that is capable to do testing up to 4x4 MIMO, which we actually don't need here since we have RedCap, and gives also capabilities to test all the 3GPP band combinations which we have here for SA testing. So RedCap, as I said, is a standalone technology. We don't have so much complexity from a band combination point of view, and here we can easily use the CMX500 OBT Lite to test all the available bands that are required for RedCap testing. What also works is we have the 3GPP conformance tests in place here, and we have a data application unit inside the CMX500 to allow all types of testing when it comes to IP testing, IMS testing. So Gotze mentioned that voice over NR is one big part. So we have a full voice over NR audio testing solution also on the CMX 500 that is relevant here for RedCap testing. From a user interface point of view, we also address all relevant parts. So in the field, you find customers that are more interested in interactive mode testing. So they want to connect the device, they want to sit in front of the instrument, change parameters, and get the measurements on the fly. On the other side, next steps could be that you go more into protocol testing. You want to script your own test cases. Here we are using a built-in sequencer, a graphical sequencer, to create own test cases. But then we also have customers who purely want to remote control the CMX 500. And here we have two ways, either by using the standard industry Skippy language, so to speak. So we can remote control the CMX 500, or customers also have a way to create test cases with Python language here, Python scripting, which is standard in the industry. So no matter which interface you're using, RedCap is implemented in all four interfaces, and you can create hundreds of possible test scenarios with our CMX 500 user interface. To help the customer with that, typically, as we are addressing R&D in the chipset industry right now, and here we need to go deep into the protocol stack, protocol testing. As I said, cell barring, bandwidth part switching is the most important part here. We have a package to help customers to create their own test cases. So we have a Python package in place, which can be used for early R&D protocol verification. We have an interactive callbox mode, which we will show you also in a few minutes, for RF and application tests, for throughput testing, for data testing. And we have also a sequencer. If you say, okay, in manual testing, interactive mode testing, I'm done, and now I want to script my own test cases in a graphical way, we have all the RedCap functionality in our sequencer. When this is all done in R&D environment, of course, this is not the last point, because RedCap devices have to be certified. There has to be some conformance part running. And we also have protocol conformance testing in place. So for GCF, PDCRB type approval, we have all test cases already available. Next step is RF, RM conformance testing. This we also have. But since we wanted to address more the protocol part here, this is what we can showcase right now. XLAPI, Python scripting package KF678 is already mentioned here. So we have around 20 typical test scenarios in place. As you can see here in that list, it starts with cell barring scenarios, attach of a RedCap device. You see it's to verify the PRUG message 3 and so on. We have extended DRX implemented, RM measurement relaxation for stationary devices is there. And of course also bandwidth part switching that gives our customers a perfect start for early R&D testing in the lab. Then we have our CM Squares interactive GUI. As you can see here, you can easily change from a normal 5G device to a RedCap device, and then all the parameterization that, for example, going down to 20 megahertz, having only one RX antenna, will automatically be done by our CM Squares user interface. The customer doesn't really have to dive deep into all the parameters. So we are doing that for him. And then you can also do these cell bearing test cases as you would do in a protocol environment. So then we have customers who want to concentrate on creating their own test cases in a graphical way. So starting with XLAPI, then having the interactive mode. Here we have a way where customers can create test cases just with the help of these blocks. And we have added one significant RedCap block that brings all the RedCap typical parameterization here. So for example, going down to 20 megahertz. So just with this one block, you can combine each and every other 5G measurement like power consumption, like voice over NR or throughput testing inside our CM sequencer. Keyword power consumption testing I mentioned before. In our CM sequencer, we have a battery life or power consumption block, which takes the measurements from our NGM power supply and puts it in a chronological way here in the test report. So what you can see here is a test run of a RedCap device that also has power saving functionalities implemented. And the typical signaling events that you can see here are correlated with the actual power consumption of the device. So usually it starts with the attach here. Then MAC padding is being activated. Here you see when no padding is applied. Then we have C-DRX activated from the network. And then also wake-up signal is been activated, and you see how the battery consumption significantly goes down here. And all these types of power consumption measurements are available on our CMX500, also for RedCap devices. Last but not least, test platform 292 is the certified test platform here for our CMX500 for 5G testing. You can see here that's a summary of 5G tests in total, also including LTE and FR1, FR2 test cases. So in total, we have 547 individual test cases validated. 521 we have at PTCRB, and you see how many band combinations we have here in GCF and PTCRB, which you all can test with the CMX500. For RedCap testing, this is the last item here. We are leading the release 17 test cases. So this is an own work item in GCF. We have the test cases available, and there are also release 15 test cases that have a release 17 RedCap configuration. And also those test cases are available on the CMX500. So if you are at the stage doing protocol conformance testing for RedCap devices, you can use our CMX500 as well in the lab. So now you've heard a lot of technical details with respect to RedCap device testing. And to better digest all this information, we would like to give you a demonstration live on our CMX500, how you can test things like bandwidth part, switching, cell access barring in our user interface, from callbox to protocol testing, application testing. Here we are remotely connected to our CM Squares user interface, and in this part of the demo we are showing our interactive mode, which is also known as the callbox mode here. On the left-hand side in the network, you see we have one FR1 cell defined in band N5. And on the left-hand side in the configuration, we can now define that we want to test a RedCap UE. And here in this configuration button, you can see that in this configuration, we do a 2RX barring like we discussed before in the slides. From the network itself, switching to RedCap UE will also limit the carrier bandwidth here to 20 megahertz. And in this case, we are testing FDD in band N5. So if we switch on the cell now, the system information will be sent out. And here in our message analyzer, we can also dig deeper in state that gives you indication about the RedCap device. And you see the device itself gives that information via message 3 here, that it is a RedCap device. On the other hand, we have also the UE capabilities view, which says it's a Release 17 device, RedCap is supported, and all the bands and parameters that are supported by the device. You can also save this UE capabilities directly into a file. What you also very nicely see is this message sequence chart that gives you the message flow of the attach. You can click into the messages and get also detailed information elements later on. So a very handy way to see what the UE is doing and how the attach is working together with the parameterization. What you typically also wanted to test is the uplink characteristics of the device itself. So typical RF multi-evaluation measurements like TX measurements, EVM versus subcarrier, IQ diagrams, spectrum emission masks, and things like that. And that's what you basically see here. So we show the measurement in real time directly on the CMX 500. On top of that, blare measurements is also a good thing. So here you can just open this in a separate tab and do the blare measurements. You see here the results over this RedCap cell. So another way how to test such RedCap devices in a more test case approach is by using our graphical sequencer, which is part of CM2's user interface. Here in this test case, we have a block which is called configure NR RedCap cell, which is exactly doing what we have done in the interactive mode. And here we combine it with a typical measurement. And same as in the interactive mode, you get prompts to activate or switch on the device. And then we do, as you can see here, the 5G registration. And what you can also combine it is you can just add the FR1 TX measurement block, or you do power consumption measurements. You can activate any other release 15 to release 17 feature that we have implemented in CMX 500 and combine it in one test case here. So as you can see here, same thing. We do the registration and then doing TX measurements and even blare measurements like we did in interactive mode, just in a more test case based approach. And once this test case has run through, we get a pass verdict. You can combine it with any other test case in a regression, and you get also the test reports with the graphical measurements as HTML or PDF, which you can then use for later post-processing of your test case analysis. So we hope that you really liked what we have presented today. On the one hand side, technical information, a bit of market aspects, as well as a real demonstration against a real device. And if you have any further requests for RedCap device testing with the CMX 500, please touch base with Gotze and myself. And I would like to thank you once again for staying with us during this webinar.
네, 지금까지 저희가 준비한 영상으로 함께 해주셨습니다. 5G RedCap 릴리즈 17 규격을 통해서 소개가 된 기능이기 때문에 아무래도 좀 어떻게 보면 좀 새로운 어떤 기술, 기법 이런 느낌도 좀 들기도 하고요. 또 어떤 새로운 어떤 시장을 창출할 수 있는 이런 기술이 아닐까 뭐 이런 생각도 들긴 합니다. 여러분들도 아마 함께 보셨겠지만 일단 제가 생각하기로는 쭉 오늘 내용들을 봤을 때 이 5G RedCap이라고 하는 부분이 어떤 뭐 LTE와 5G처럼 어떤 독립된 기술 같은 개념보다는 이게 5G라고 하는 기술을 업그레이드하고 좀 확장을 한 개념으로 뭐라고 표현해야 될까요? 그 5G의 위에서 돌아가는 어떤 서브셋 같은 개념? 이제 요런 기법 정도로 이제 생각이 되고 있고요. 그렇게 만든 가장 큰 이유는 뭐 IoT라든지 혹은 요런 그 뭐 특화망이라든지 웨어러블이라든지 요런 시장들을 위해서 좀 더 어떤 최적화된 어떤 그 분야를 만들어 보자. 5G를 그냥 퉁쳐서 5G라고만 할 게 아니라 요런 쪽으로도 좀 더 최적화되어 있고 스마트폰은 스마트폰대로 좀 더 최적화되어 있는 요런 어떤 서브셋들을 만들어 보자. 이제 이런 식으로 접근을 하게 된 내용이 아닐까. 이렇게 이해가 되는데 어떨까요? 제가 이해한 부분이 어떻게 좀 맞을까요?
네네, 맞습니다. 네.
일단 5G라고 하는 자체, 이 5G RedCap이라고 하는 부분이 완전히 서로 독립된 어떤 그런 부분은 아니기 때문에 5G 시스템에서 돌아가는 그런 어떤 기술적인 부분이다. 뭐 이렇게 이해를 해주시면 조금 좋지 않을까라고 생각이 되고요. 오늘 질문들이 갑자기 좀 많이 늘었어요. 지금 저 중간중간 저희가 계속 봤었는데 이 질문이 갑자기 확 들어옵니다. 그래서 아마 여러분들 이제 지금 내용 쭉 보신 다음에 한꺼번에 이제 질문들을 올려주신 것 같은데요. 일단 저희는 앞에서부터 질문들을 조금 차근차근 말씀을 드릴까 하고 생각을 하고 있는데, 이제 항상 그렇듯이 문제는 시간이죠. 오늘 저희가 준비한 시간이 3시까지입니다. 그래서 시간이 조금 많이 남은 건 아니기 때문에 오늘 여기서 저희가 답변을 드릴 수 있는 부분들은 저희가 답변을 드리겠지만, 그렇지 못한 부분들은 저희가 또 따로 이메일로 여러분들께 개별적으로 답변을 드릴 수 있도록 그렇게 준비를 해야 될 것 같고요. 이 점에 대해서는 뭐 저희가 뭐 계속 여기서 여러분들께 말씀을 드리면 좋겠지만, 그렇지 못한 점은 좀 양해를 부탁드려야 될 것 같습니다. 참고로 오늘 참석하신 분들께는 저희가 따로 이메일로 뭐 참석에 감사드린다는 메일을 드릴 겁니다. 그리고 그 내용에는 저희 다시 보기 영상에 대한 부분과 발표 자료 다운로드 받으실 수 있는 경로에 대해서, 물론 기본적으로는 저희 로데 슈바르즈 코리아 홈페이지를 통해서 저희가 공개를 할 거고요. 그 링크에 대한 부분들을 그 참석 감사 메일에 따로 포함을 시켜서 드릴 예정이기 때문에 이 부분들은 잠깐 기다려 주시면은 여러분들께서 확인하실 수 있을 것 같습니다. 예. 그 질문 올려주신 부분들부터 쭉 차례대로 한번 볼게요. 그래서 여기 피터봉 님께서 올려주신 질문이네요. 첫 번째 질문이었던 걸로 기억을 하는데요. 발표 자료 공유, 이 부분은 좀 전에 말씀드린 것처럼 저희 홈페이지를 통해서 여러분들께서 그 다운받으실 수 있도록 링크를 제공을 해드릴 예정이고요. 요 링크에 대한 안내는 말씀드렸던 것처럼 메일을 통해서 여러분들께 내용을 드릴 수 있도록 그렇게 하겠습니다. 그리고 두 번째 질문, 현재 업계 동향 및 앞으로의 발전 방향에 대해서 문의해 주셨네요. 김종호 매니저님, 일단 지금 제가 생각하기로는 이 업계 동향, 아까 뭐 쭉 제가 이해한 걸 말씀을 드렸었습니다만은, 이게 사실 아직 상용화가 된 건 아니잖아요.
네, 네, 맞습니다.
예, 지금 상용화 이전이기 때문에 뭐 지금 현재 어떻게 돌아가고 있다 이런 부분을 말씀드리기엔 저희 입장에서는 조금 섣부른 감도 있을 것 같고요.
네, 네.
앞으로의 발전 방향은 아까 쭉 설명해 주신 것처럼 웨어러블이라든지 사물인터넷 뭐 이런 부분들을 말씀을 해 주셨잖아요.
네네네.
예.
뭐 인더스트리 4.0 관련해서 이 그 산업 영역 쪽에서도 많이 사용될 수 있을 것 같고요. 예.
이 레드캡이라고 하는 게 우리가 지금까지 사용해온 이 스마트폰이 메인 타겟이 아니라는 점은 확실한 거겠죠.
네네, 맞습니다.
예, 그렇다면은 아마도 이런 액세서리, 우리 보통 이야기하는 이제 그 웨어러블 같은 경우 이제 대표적으로 스마트폰과 연동되는 액세서리 개념이 될 것 같기도 하고요. 특히 요즘에 보면 뭐 스마트 홈이라든지 스마트 시티라든지 이런 개념도 굉장히 많이 나오는 것 같은데,
네네.
이런 쪽으로 주로 어떤 타겟을 맞춰서 계속 발전할 것 같다. 뭐 이런 정도가 아마 예상되는 방향이 될 것 같아요.
네네네, 맞습니다.
예. 그래서 스마트폰과는 약간 트랙은 달라질 수 있지만 결과적으로는 하나의 5G 안에서 돌아가는 그런 어떤 뭐라고 해야 될까요? 약간의 변화를 준 내용? 뭐 이런 정도로 여러분께서 분야가 약간 달라지는 거다 이렇게 보셔도 크게 무리는 없지 않을까? 뭐 이런 생각을 하고 있고요. 임종택님 저 질문해 주신 내용입니다. 기업에서 5G 레드캡을 도입하려고 한다면 고려를 해야 될 사항이 무엇인가? 이 부분은 일단 제가 이해하는 거를 먼저 말씀을 드리자면, 이 5G 레드캡이라고 하는 게 어떤 특별하게 뭔가 요것만 따로 들어온다든지 이런 건 아니잖아요.
네네, 맞습니다.
예, 이게 어떤 5G를 응용하는 어떤 기술의 한 섹터를 의미를 하는 거지, 이게
네네.
뭐 어떤 5G 레드캡이라고 해서 레드캡 어떤 그 네트워크가 따로 있고 막 이렇게 돌아가진 않을 것 같아서요.
네, 이게 뭐 퍼블릭 네트워크나 아니면 넌 퍼블릭 네트워크에서 다 사용될 수 있는 거기 때문에, 네, 레드캡을 별도로 도입하지는 않습니다.
지금 퍼블릭 네트워크, 넌 퍼블릭을 말씀하신 부분은 이제 프라이빗 네트워크, 그 특화망을 기준으로 지금 말씀하신 것 같아요. 예. 그러니까 결과적으로는 이게 우리가 5G, 네트워크에서 5G를 도입을 한다, 혹은 단말에서 5G를 지원한다라고 한다면은 그에 맞는 적절한 부품이나 어떤 기술 적용을 한 내용들을 가지고 이제 서로 동작할 수 있게 구축을 한다, 이런 의미가 될 것 같아요. 그래서 지금 말씀하신 이 5G 레드캡 도입이라는 부분도 결과적으로는 이 5G를 도입을 해서 어떤 프라이빗 망을 구축을 한다, 혹은 뭐 웨어러블을 만들겠다라고 할 경우에 거기를 구현하는 어떤 내용으로서 레드캡을 적용을 할 거냐 말까, 이런 식의 그림이 되지 않을까 싶은 생각이 드네요.
네네. 일단 기업에서 레드캡을 도입한다는 것 자체가 일단 무선 IoT 환경을 만들겠다는 의미일 수도 있으니까요. 근데 그거를 이제 도입하려고 이제 고려를 해야 될 사항은 일단은 우선 네트워크가 일단 레드캡에 대한 지원이 일단 우선이 돼야 되는 상황인데 지금 현재까지는 아직 상용화가 아직 안 됐기 때문에 일단 그 부분이 우선적으로 돼야 될 부분들이죠. 네.
예. 일단 지금 단계는 어쨌거나 이제 연구 개발 단계라고 보시는 게 맞을 것 같기 때문에 추후에 상용화 시점에서 또 어떤 부분들을 고려해야 될지 추가적인 부분들이 또 얘기가 되지 않을까 싶습니다. 그리고 다음 말씀해 주시는 이 박일규님 질문이 있네요. 5G 레드캡 주요 대상 고객사들. 이 비즈니스 도메인까지 이제 질문을 해 주셨는데요. 아까 지금 계속 말씀드립니다만 이 5G 레드캡은 이 5G NR이라고 하는 기술이 타겟팅하고 있는 이 URLC, IoT, 그리고 이 스마트폰. 보통 우리가 이야기해 오던 이 스마트폰에 연관된 이런 내용까지를 모두 다 포함을 했을 때 그 중에서도 IoT와 이런 부분들을 주로 대상으로 하기 때문에 방금도 얘기 나왔습니다만 그 5G 특화망이라든지 이런 부분들을 고려하시는 어떤 분들이 계신다면은 그런 기업들 같은 경우에 그 특화망을 뭐 레드캡을 적용을 할 거냐 아니면 기존의 5G NR을 이용할까 뭐 이런 식으로 아마 선택하실 수 있는 상황이 되지 않을까 싶어요.
네.
예, 그래서 어떤 구현 방법에 대한 이야기를 하는 거기 때문에 그렇게 이해를 해주시면 될 것 같고요. 그래서 아까도 잠깐 말씀드렸습니다만은 현재까지는 상용화 이전 단계입니다. 릴리즈 17이 배포된 후에 새로운 업데이트된 규격으로서 언급이 된 부분이고 현재 R&D 단계이기 때문에 지금 말씀하신 이런 비즈니스에 대한 활용처라든지 혹은 어떤 주요한 어떤 그 공급사라든지 이런 부분들도 아마 여러분들께서 추후에 상용화 시점에서 또 다시 내용을 보실 수 있지 않을까 뭐 이런 생각이 들기도 하고요. 말씀드린 것처럼 좀 한 3개, 4개 정도 지금 저 질문을 앞에서부터 차근차근 말씀을 드렸는데 지금 벌써 시간이 3시가 조금 넘어가고 있습니다. 그래서 아마 죄송합니다만은 지금 오늘 지금 이 뒤편으로 지금 질문이 굉장히 많이 올라와서 갑작스럽게 또 많이 이렇게 그 질문들을 주셨는데 이런 부분들은 저희가 잊지 않고 여러분들께 꼭 그 따로 회신을 드릴 수 있도록 그렇게 좀 양해를 좀 부탁을 드려야 될 것 같고요. 제가 준비된 시간이 지금 거의 다 됐기 때문에 오늘은 이 정도쯤에서 여러분들께 아쉽지만 또 정리를 해야 될 것 같습니다. 오늘 날씨가 또 갑자기 추워졌어요. 어제 비 온 이후에 갑자기 추워졌는데 오늘 참석하신 모든 분들 모두 다 건강하시길 바라고요. 참고로 또 뭐 저희 쪽 잠깐 그 광고 말씀을 드리자면은 저희 회사가 저희 로데 슈바르즈 본사 독일 본사입니다. 지금 11월 17일을 기준으로 해서 90주년이 됐어요. 저희 창립 90주년인데 여러분들 그래서 아마 여기 참석해 주신 분들 중에서도 저희 이제 그 이벤트 참석해 주셔서 이제 축하 말씀 남겨주신 분들 굉장히 많으실 것 같아요. 다시 한번 말씀드립니다만은, 먼저 참석해 주신, 그리고 저희에게 축하 말씀 남겨주신 모든 분들께 다시 한번 감사를 드리고요. 저희 지금 11월 말까지 한 이틀 정도 남은 셈인 것 같은데요. 11월 말까지 계속 이벤트 진행하고 있기 때문에 저희 그 블로그, 저희 공식, 로데 슈바르즈 코리아 공식 블로그를 통해서 여러분들 여러 가지 다양한 기술 소식이나 또 관련된 어떤 이벤트 내용들 또 참조하시면서 또 내용들을 보시면 좀 더 재밌는 이야기들 보실 수 있지 않을까 이런 생각이 듭니다. 네, 시간이 다 된 관계로 저희는 오늘 준비한 내용을 이 정도로 정리를 하도록 하고요. 다시 한번 참석해 주신 모든 분들께 감사드립니다. 저희는 오늘 이 정도에서 정리하겠습니다. 감사합니다.